Well, good afternoon. I'm enjoying a wonderful Sunday afternoon in the sun and my newly refurbished or rebuilt radio here, SX-99. My name's Albert. This is Hallicrafters Rehabs. And by the way, the reason why I couldn't put the side screws in is because I forgot what I told you in the first episode, which is in order to take the side screws out of the case, you have to have it upside down. And that's because there's a very tight clearance between the bottom of the chassis and the lip of the front face. And that tight clearance, there's a small part of the case, or actually a lip of the case, that slips between that chassis and the edge of the front face. And unless it's upside down, that clearance is not there. The weight is just too much. So figured that out. There are a few little things that I want to address in it when I get it back apart. But it is a beautiful afternoon in the sun. By the way, sunspot cycle 25 has started. A sunspot was detected in the new cycle. I think it was this past week, and you could already tell a little better reception on shortwave. I picked up the Malaysian Sarawak stations for the first time in years earlier this week, because there was just one little measly almost started sunspot. So we're on our way. We need to get all our radios working good. And so what I'm going to focus on, even before I start rebuilding that SX100, is doing some performance testing on radios. And I haven't been wasting my time here. I've been watching YouTube videos and learning about things. Some people learn audio learners, others are visual learners, others are tactile learners, and I'm a YouTube learner. There's one channel, it's a very simple channel, it's Knowledge in Depth, and it's in Hindi, so I don't think any of my subscribers listen to Hindi, but it's sort of Hinglish, in Hindi and English, but he does a nice job of summarizing things, very much like All American 5, that wonderful channel. But basically, I'm going to be doing some performance testing on radios, and not just this one, but in comparison with the others. So radio performance is really divided into three areas: sensitivity, selectivity, and fidelity. I think by the time I'm finished with these, you'll be all wanting to have tube radios instead of solid state, because there are a lot of advantages to solid state radios. They're very convenient to use, but we will see. And we have one of the very best shortwave radios to compare against, which is that Japan radio in our something or other 535D. Sensitivity is related to how much of the signal is getting through to the radio in relationship to noise. Now, if a radio, if there was no noise, okay, then any radio could pick up any signal, theoretically. You might have to put some radios or RF amplifiers or preamplifiers in tandem to boost the signal, but the most fate of signals is out there on that 100-foot aerial right now, coming in. Magnetized field of amplitude, whatever. And what keeps us from hearing it, even the most sensitive, is the noise. And there's two kinds. There's a noise from the atmosphere, and there's an internal noise. And actually there's a third. I don't know, you could call it the noise of the electronics itself. Now, there's a theoretical low limit of noise based on temperature. We could call it temperature noise. So all we're about in sensitivity is signal to noise ratio. And how much of that signal is being canceled by the noise. So when we do our sensitivity determinations, it's minimum detectable signal. You take the faintest of code weighted signals you can come up with and find at what level you're 3 dB above the total noise. Now the internal noise is actually a noise figure associated with the radio, and all of its internals, the tubes, the configuration, how good a job I did, how bad a job I did, and things like that. The atmospheric noise you really is there all the time, comes from our sun. And it's a beautiful thing, our sun. It has a full spectrum of light. I've done a lot of study in astrophysics, and the sun, God has done a beautiful job of making the sun out of nothing. And when he did so, he gave us infrared radiation for warmth. He gave us a full spectrum of photon in its own electromagnetism that gives us the colors that we see, and then it gives us ultraviolet. And so we enjoy being outside killing all viruses, because ultraviolet light is a virus killer. So we will be getting out of this thing, and let's get back to radios. Anyway, so we already have a natural virus killer in our sun, and soon the governments will catch up with the science. So we'll be measuring sensitivity to noise ratio, and also there's an aspect of gain associated with this too. Then selectivity is really, now I was watching a video from All American 5. He did a great job. He used color coding to show how a radio uses an oscillator to add to the RF signal. This is plus 455. It's operating at the frequency plus 455. And this is operating at the frequency. And he showed how the color goes through, we'll just block diagram it, the mixer. And on the other end of the mixer is what I call a bandpass. It's not actually an IF amplification stage, it's a bandpass. It's a filter. It's configured like an IF amplifier. It also has a center tap, and this center tap is where you get your designed selectivity, usually around 10 kilohertz or whatever. And these have a second center tap, which is associated with the crystal. But he does a magnificent job of showing how the colors blend and add and subtract. And you've got 4 signals coming through here. You've got the frequency, you've got the frequency plus the 455. You have the frequency minus the oscillator frequency, which is 455. And you have the frequency minus 455. And all this is doing is filtering for that. So that is what a mixer does. But I really recommend, it's about 4 years old now. Go onto his site and look at that video. Then of course selectivity continues with IF amplification. Now the SX-100 and the SX-79 have two stages. They have a converter, we will say. There's the first stage. This has 1650 kilohertz as its first IF. I'm telling you, I'm studying about this thing before I even open it up and start rebuilding it. And this one, and then a 50 kilohertz. And we'll get into why when we get to that radio. This one has a 2075 kilohertz and a 455, traditional 455. And these really do a good job of filtering out images and amplification, and they really are great performers. Now in the solid states, you don't even know how many. I mean, they'll have dual conversion, I'm sure, but they'll have amplification is cheap in solid state, so they have their own way of dealing with these things, but when we will compare with a very good solid state. Then the last thing is fidelity, and that's simply how much of the amplitude modulation is being reproduced into the speaker along its range, and we'll look at that. So those are the kinds of tests we're going to delve into. There's one more test that I don't know where you put it, and that really is the drift. Something you don't really deal with very much in solid state. But it's important with the tubes because tubes have drift in themselves. And the shortwave radio, these particular 99s had bad drift. But I want to tell you, I put in that 10,000 picofarad mica capacitor right in the oscillator circuit where they had a tiny chief. It's basically 0.01 microfarad. They had a tiny chief, and there may have been a reason back in the day there are a lot of tiny chiefs in this radio, and it was probably a cheap paper, however encased in plastic. It somehow, I bet you it was, I'm just guessing, it handled temperature coefficient better. And so it was, I was wondered why they use those terrible things. And so there's less drift in these things when they came off the factory. So everywhere you see a tiny chief, I'm thinking from now on, we need to be looking at Np0 capacitors, and they do have them. They're blue, okay? They look just like, they're a mica capacitor. They're probably just selected for, I don't know, they're multi-layered ceramic. That's what they are. They're not mica. And the Np0s are blue, and they probably don't drift. They're probably the modern equivalent to a tiny chief. I'm kind of guessing out loud here, but I'm thinking the drift really, I haven't measured it yet, but we will see, and we will confirm whether or not this radio, I should be turning down this thing. I'm not listening to it. I don't think you are either. But we're going to see that probably we're going to start using these a whole lot more. Anywhere I see a tiny chief, I'm going to start thinking about, well, there must have been purpose behind this, because the other capacitor was the bumblebee, and they're just like, you know, draining off our spurious RF and things like that. The typical capacitor work in a radio, whereas this was a tiny chief that this replaced. So that's my thinking. So enough talk. The next thing I'm going to do is I'm going to go and actually I'm going to go through an alignment of the SX-100, and we'll see we'll learn some things about why they chose these frequencies, and some pluses and minuses. But hopefully we can get I've got one that's operating now, which has never been, you know, really carefully aligned with. I'm going to use all my best instruments on this. When we do these measurements in comparison, I've also thought that I want to use more common test instrumentation, like a non-calibrated RF signal generator, because most people don't have those calibrated ones, or you know, you have to plunk down $200 or $300 to get one of them new or used on the auction site. In the same thing, we'll go through the alignment without the spectrum analyzer and do some of those measurements and things like that, as well as with the spectrum analyzer, so that you can see how it's done the way the instructions say, and then see what benefits better instrumentation can do. So that's what I've been thinking about while I've been using my YouTube learner skills and enjoying the weather out here in the shortwave radio, which is performing very well. This is a real short video. This is Albert at Hallicrafters Rehabs, and thanks for watching, and thanks for the new subscribers.